Welcome to the lesson on the improved phase of the Six Sigma DMAIC model. Upon completion of this lesson, learners will be able to explain the improved phase and recognize the tools associated with the improved phase of the DMAIC model. The improved phase builds upon the insights gained from the analyzed phase. It concentrates on the specific areas of improvement that were identified through careful data analysis. During this phase, team members engage in collaborative brainstorming sessions to generate potential solutions for addressing these improvement areas. Now that the areas for improvement have been identified, the team can put their ideas to work. During the improve phase, teams work to develop and evaluate multiple solutions for each identified problem. This process involves proposing various alternatives and then rigorously testing them to determine the most effective approach. To facilitate this effort, several tools are employed. These include design of experiments, abbreviated as DOE, and force field diagrams. Additionally, teams often revisit tools used in earlier phases, such as brainstorming to generate ideas, affinity diagrams to organize information, and check sheets to collect and analyze data. Six Sigma often uses a method called design of experiments to optimize the performance results of a process. Design of experiments, or DOE, is a method used to test the interactions of different factors and their effects. This approach is characterized by three key components: factors, which are variables that can be altered in the experiment; levels, representing different settings or values for each factor; and responses, which are the measurable outcomes of the experiment. DOE comprises various types of experimental designs. Full factorial designs test all possible combinations of factors and levels, providing comprehensive data but potentially requiring significant resources. Fractional factorial designs use a subset of these combinations to reduce experiment size while still yielding valuable insights. Response surface designs are employed to explore relationships between several factors and one or more response variables, often used for process optimization. Let's create a simple design of experiments example for an electric vehicle production environment, focusing on the final assembly process. It demonstrates how different factors in the production environment can be systematically tested to improve both efficiency and quality. The DOE includes three factors: assembly line speed, 20 versus 25 units per hour, number of workers per station, either 2, 3, or 4 workers, and tool organization method, whether traditional toolbox or smart tool tracking system. Each factor has different levels, and the full factorial design allows for testing all possible combinations. An example of the experimental runs is shown in the table here. After completing the experiments, a comprehensive analysis of the results will be conducted. This analysis will focus on three key aspects. It would determine the main effects of each factor, in this case, assembly line speed, number of workers per station, and tool organization method, on both the assembly time and quality score. The analysis would explore any interaction effects between these factors, revealing how they might influence each other when combined in various ways. Based on these findings, the analysis would aim to identify the optimal combination of factors that minimize assembly time while simultaneously maintaining a high-quality score. This thorough examination of the data would provide valuable insights for optimizing the electric vehicle assembly process. Potential outcomes suggest faster line speeds might reduce assembly time, but impact quality. More workers could improve both metrics with diminishing returns, and smart tool organization might consistently enhance both time and quality. This DOE will guide the production team in balancing assembly speed and quality, ultimately improving the EV assembly process. A force field diagram is a tool used to identify driving and restraining forces and their impact on the equilibrium of a system. Driving forces have a positive impact on the process and are a step toward improvement. Restraining forces are the opposite of driving forces, as they restrain improvement. After the team identifies the driving and restraining forces, they attempt to enhance the driving forces and minimize the restraining forces. For each driving and restraining force, a weight can be assigned to represent the given force's impact on the system. A weight of 1 is weak and 5 is strong. A template for creating a force field diagram is shown here. The alternative solutions should be tested using design of experiments, force field diagrams, and methods discussed in previous steps like affinity diagrams and check sheets. By combining the results of the improvement tools, the best solution to each problem is selected. The team then must create an implementation plan with guidelines for how to integrate the improved solution into the existing system. The deliverables of the improve step include an optimal solution to the problems in the system and an implementation plan for each solution. In summary, the improve phase of the DMA-IC model utilizes the results of the analyze phase to focus on improvements to the system. Tools in the improve phase include design of experiments and force fields diagrams. Through the use of these tools, the team can come up with ways to improve the production process and can test to determine which improvement is most effective. Thank you.